Why does a Boeing 737 Tyre experience more force than the landing weight of aircraft itself? The landing weight of Boeing 737 is about 66 tons, which is equivalent to 5 heavily loaded trucks. Now imagine all this hitting the runway at 270 kilometers per hour. Even taking a normal sink rate of about 1.2 meter per second, the initial load factor caused because of this is around 1.5 G to 1.6 G. Using Newton's second law, where force is equal to mass times the acceleration, with the moment at touchdown, creates an instantaneous load of about 100 tons. Yes, 100 tons per traction second. Now, another important thing to remember. At the time of landing, usually the aircraft lands at nose-up condition. Meaning of this, the nose landing gear has not touched the ground yet. So at this instantaneous second, all 100 tons of the load is passed through the main landing gears alone. The main landing gear for Boeing 737 has just 4 tires. Yes, just 4. So all this 100 tons of load has to pass through these 4 tires in a fraction of second. Assuming linear distribution, each tire takes about 25 tons of load. But that's more than a fully loaded bus concentrated in a small piece of tire. Yet, nothing bursts. So how does that tire survive the spike? The answer comes from something called non-linear stiffness. And this non-linear stiffness is very different from helical spring stiffness, which we learn in physics textbooks. 25 tons per tire, and it doesn't burst like a balloon. Why? Because a tire doesn't copy-paste ascendance like an Indian engineering student. Speaking of Indian engineers, let's take helical spring. Add a load of 10 kilograms. It compresses by 10 I. Now add a load of 20 kilograms. It compresses by 20 NO, and so on. If you plot this behavior in a graph, you simply see a straight line. Same stiffness, always predictable. No surprises. Now, do the same with the Boeing 737 tire. At initial nodes, we can see that the tire behaves very similar to a helical spring. But as the load increases, it compresses much lesser and lesser. So when the peak load of 25 ton reaches the surface of the tire is at the absolute stiffest point and the deflection is absolutely minimal. Yeah. This can be compared with the behavior of a sponge. Her squeeze varies. Continue to squeeze it, the resistance gets harder and harder. The sponge resists more as you squeeze more. Similar thing happened with the tire, but not due to any material properties, but due to the design of the tire. I always tell my students, don't be a helical spring, be like an aircraft tire. As things get harder, the stronger you become. My student Lokesh Surendra says, Anna, I'm already like a tire. Then I got to know he's like a cycle tire. Got punctured in the first semester itself. Tire gets progressively stiffer as the load increases. But we never answered the main question. Why? What causes this non-linear behavior? Turns out a single parameter is responsible for the whole show. Pressure. The tire has a footprint on runway called contact patch area. How is this related to pressure? Force is equal to rate of pressure times the contact patch area. When the aircraft is at rest, contact patch area is large enough. So the pressure of the Boeing 737 tire, which is around 200 psi, automatically balances the surface weight of the aircraft. No adjustments are needed in this case. Now, at the time of touchdown, the force spikes about 25 tons. There is no way of pumping air in tire mid-landing. So as your rated pressure is fixed, the adjustment that can be possible during touchdown is the contact patch area. The contact patch area expands, so contact area for the same rated pressure. So in this case, higher loads could be withstood with the same rated pressure. This is exactly why the curve flattens. As more tire structure engages the ground, the resistance builds faster and lesser amount of deflection happens by the tire. I will always tell my students, when pressure is fixed on you, expand your presence, grow your content, and always stay grounded. My student Lokesh Surendra said, Anna, I already did this in an exam hall. Pressure was too much. So I expanded my presence, sat wider, and grew my contact with the next guy.